I'm Neeraj Mansingh and this is our PRML project. We have worked on the CIFAR-10 dataset to create an image retrieval system. The problem statement was simple. Given a query image, our model retrieves 5 random images that are the most similar to the query image. For example, here we see an aeroplane and the 5 aeroplane images retrieved from the CIFAR-10 dataset. Let me describe the CIFAR-10 dataset. It is a labeled dataset containing images that are 32 into 32 pixels in size. These are RGB images divided into 10 classes: aeroplane, automobile, bird, cat, deer, dog, frog, horse, sheep and truck. The dataset includes 50,000 training images split into 5 batches of 10,000 images each and a separate 10,000 test images. It is commonly used for image classification tasks. The pre-processing techniques we used are PCA, which reduces the dimensionality of the images, HOG. It extracts important textures, lines, curves, and gradients from the images. We also used hybrid approaches like PCA and HOG together. For the CNN models, we used ResNet 50. It is a convolutional neural network pre-trained on ImageNet that extracts high-level features, and QuickNet. It is a lightweight CNN similar to ResNet, though not as effective. These are the 10 classification models we used, out of which ANN gave the best results. But XGBoost was not far behind ANN. ANN gave an accuracy of 89.76% when trained on ResNet data, but XGBoost also gave an accuracy of 86.39% on ResNet data. Now let me explain the experimental results of ANN. Here for trial 3, the validation loss is above the training loss. Also, the validation loss is quite in a zigzag manner. This indicates overfitting and confusion. Here, training data is always above the validation loss. It is a clear case of underfitting. After using a dropout rate of 0.5, which randomly shuts down 50% of the neurons in each layer, the model improved. Although there are few zigzag here, but it is quite less as compared to before. When we used a learning rate of 0.001 in Adams optimizer, along with a dropout rate of 0.5, we see the loss curve has improved. It has smoothened out nicely, and also training loss is above the validation loss for around 25 to 30 epochs. This indicates that the model is not overfitting on the training data, and also the model is not confused. This is the confusion matrix. Here we see that dogs are commonly misclassified with cats and vice versa. The key observations are as follows. The ResNet feature performed consistently than other feature sets. Also, feature choice were more important than the classifier itself in many cases. And QuickNet was an efficient alternative as it was fast and light. Also, ANN models benefited from dropout and learning rate scheduling, which helped to reduce overfitting and improved the generalization. So the conclusion is that while the deep learning models performed quite well on the CIFAR-10 dataset, the classical models were not too far behind. When the classical models are coupled with feature extracted data and proper parameters, they gave a tough competition to the deep learning models. So we have to combine good features with the right model, which will boost the accuracy. Also, simpler models can be competitive if it is optimized well. This is a snapshot from our front end for the deep learning model. Here we put an aeroplane and it has picked out the top 5 similar images from the CIFAR-10 dataset. So I would like to thank you all on behalf of my group. Thank you.